Hello, my name is Steinkrauss and I'm with company Unified Automation. We are doing software development kits for integrating OPC UA technology into existing devices, systems and software. Today I want to talk about the OPC UA transports and the client-server and the publish-subscribe communication model. A simple analogy of the two different communication models, the client-server and the publish-subscribe model, is the difference between a phone call and a telephone or web conference. In the client-server model, same as in a telephone call, you have two participants and they have a direct connection. They can ask a question and respond to that information directly. And even if you have more calls at the same time, you can switch between the callers, but every single caller is treated individually. So this is a client-server model. On the other side, the publish-subscribe is more like a telephone or like a web conference. There's one, the publisher, talking, and all the others, the subscribers, are listening. There's no direct feedback if one of the subscribers has not understood the information or even dropped the line. The publisher is just repeating all the time the same information and the others are just listening. So these are totally different mechanisms for communication, but they are good for different use cases. And OPC UA covers both the client-server and the publish-subscribe model. First, I want to talk about the client-server communication. So, between the server and the client, there is a connection, a session. And this session context is required for this peer-to-peer connection. We have a safe transport and acknowledgement of every message. And we have even something like data change, which is also known as long polling. So there's a way of notifying on change inside this model. It is more like a private connection between a client and a server. But the disadvantage is this communication model is resource consuming if you have many connections, because the server is treating every connection individually. So the use case is for asynchronous communication on demand for a huge amount of flexible data. This is typically used in MES systems or SCADA systems, also for IT and cloud communication, and even for on-demand controller-controller communication. This model is very useful. In addition to the information model, we now have the services. The services are an abstract API to access the information inside a server. And these services are grouped into sets of services. Altogether, there are 36 services defined by the OPC Foundation, and they are in different sets, groups for their functionality. So we have services for creating a secure channel, we have services for creating sessions, for node management, adding and deleting nodes in a server. We have an attribute service set, which is maybe most important because it has a read and the write access to the attributes, so to the values of a node. And we have the monitored item service set, which is to notify on change. And we have the service set for methods to invoke method calls. And so all these services are predefined by the OPC Foundation, and they are an abstract API to access the information in the server. On the left side, we have the server with the information, and on the right side, we have the client that wants to access this information. So the client is the active part, and the client is doing a create session service call. And the server responds when the session was successfully created. So it's a request response to create the session. And then the client has to create a subscription. And then the client is browsing in the information space of the server to pick and choose the items he's interested in. And then it's creating the monitored items, so the items that it wants to monitor. And those monitored items can be for data or for events. These are the representations of the real values in the data source of that server. And now we have the publish service, which we want to look into detail. First of all, the information is scanned by the server or is notified in case of an event. Then the monitored item can filter this information based on filter criteria you can define. And then the data can be queued and then published to the server if a change of the value, for example, was detected. And so the data is only transferred if the data has changed. If the data has not changed, it's not transferred. This reduces the bandwidth on the wire because you only transfer if you need. Now, first of all, the client is sending the publish request. This publish request is then queued in the publish token queue. And whenever the server detects that it wants to send the information on change, for example, then it takes this publish token and sends back a response to the client that contains the information. And if nothing has changed after a while, the server will send a keep alive, which is an empty response on a publish. So by this request response, the client is notified for all the monitored items of interest when the value has changed. But of course, the client can also read or write data in the server using the read or write service calls. For the request response inside the client-server model, we have different protocol bindings. We have a binary data encoding that runs over TCP, but we also can send the data binary encoded over an HTTPS channel using TLS transport. So the services itself are independent from the transport protocol. We also had a web service binding, but that is now deprecated. In more detail, the protocols for the client server are shown on this graphic. As you can see, there's a layered architecture. On the top, we have the data encoding. Then we have a message security layer where we use UA secure conversation to secure the messages inside the content. And then we have the transport layer where we use an OPC UA TCP transport protocol, which is based on TCP. And as you can see, we can also run it over HTTP and TLS, so we can run it over HTTPS. And for the binary OPC communication, there's an IANA registered port, which is the 4840, and the binary protocol, so the native binary on TCP is a mandatory protocol. That's why it is shown in green here. The second communication mechanism in OPC is a publish-subscribe communication. So this is a UDP-based PubSub. It is connectionless, and it can use a broker, but it can also be used without a broker in a local network. It is a fire and forget transportation, so the publisher sends out the information and does not know if any subscriber has received it. It is more like public information if all the subscribers get the same data. The advantage is that it has very low resource consumption inside the server, because the server only needs to send the data out once, independent of how many subscribers are interested in this information. Secondly, it can be used cyclic. So the publisher can repeat the information and cyclically can send out the information to all the subscribers. The use case is synchronous communication for a small amount of mostly fixed data. This can be used for field-level communication. And the publish-subscriber model using brokers in between is typically used for cloud communication. So for those use cases, we have the publish-subscribe communication. The PubSub specification was released in February 2018, coming out with the version 1.04, and it's the part 14, the PubSub communication. It's an extension to the existing architecture of specifications. The publish-subscribe extension at the one time adds information model. It adds a configuration model for describing the messages that are sent out through this communication channel. There's configuration for the connection, for the metadata, so the description of the data, and for the data set itself, so for the content of the message. And this description is again sitting inside the OPC server built-in model. In addition, we have security configuration. So we have security groups and security keys that need to be exchanged if we want to publish information encrypted. And all the receivers, the subscribers, need to get the key in order to decode the information. This is an extension, but no change to the existing layered architecture of OPC UA. For the publish-subscribe, we also have different protocols that we use to transport the information. This message-oriented communication pattern can be used for one-to-many communication, it can be used for cloud communication, and in a cyclic and time-sliced manner, it also can be used for deterministic communication. The most important and first release protocol we have is a UADP over UDP. This is a mandatory way of communicating. But we also have AMQP and MQTT as a transport protocol for the cloud communication. And we can run the UADP over the time-sensitive network, and then it will become even deterministic. So we have pre-configured data content that forms the message, and this can be used for different use cases. To go more into detail of a publish-subscribe communication, we have on the left side the publisher with the information it wants to publish, and on the left side we have the subscriber that's going to receive this information. The OPC publisher defines the data he wants to publish in a dataset collector, which is a list of filtered values he wants to send. And this data comes together with a dataset of metadata that describes this information. And this set of values can contain values, but it can also contain event information. Then we have a protocol-specific part in that publisher, which first consists of the dataset writer that encodes the information, in this case into a binary UA binary format, and then a network message writer that actually puts the message on the cable into the protocol, in this case the UDP, and then it is sent over to the subscriber. This, for example, is used for controller-controller communication or from controller to I/O device communication. But we can have also other encodings, and we can have other transports. For example, the dataset writer can encode directly into JSON format, and then this JSON message can be sent over AMQP or over MQTT, for example, to any cloud system or IT system that consumes information in this format. So finally, the OPC communication framework consists of course, the device and the nice description of the information. And we have the possibility with the client-server communication path to do request response, on-demand acyclic communication, read, write, browse, invoke, notify on change. This can be used for configuration, for reading the metadata, for reading security information. We have file transfer, we can do events, we can read historical information. And in addition to that, we have the PubSub communication channel, which can be used, for example, with or without a broker to publish data into the cloud. But it can also be used to publish data to a different device. For example, for controller-to-controller communication. And if we do that cyclic, and if we use deterministic transport, like for example the TSN, or in future the 5G, we can have deterministic communication from controller to controller or from controller to any kind of I/O device. So in the end, we have devices that expose data and we have systems that consume data, and we can use OPC UA communication framework to do this communication for any kind of use case and any kind of information. This was a presentation for the OPC UA Transport Client Server Publish Subscribe. Thank you very much for listening.